uh, there are some uh, slides which are related to some theoretical part of the chapter. Okay, for that you should see the video. Okay, already uploaded yesterday. I'll start with the numericals. Basically, the first one is related to the roundabouts. Okay, and it is related to selecting the number of lanes for the roundabout. Okay, so the roundabouts can have 1 or 2 lanes. Okay, more than that is considered confusing and dangerous and so on. That's why we have it. Okay, so we can become good drivers. Okay, so this is an example. A city is considering the installation of a modern roundabout for North Main Street and East 30th Street. Okay, peak hour volume estimates for the construction here are shown in this table. We have to explore the feasibility of a single lane and a 2-lane roundabout at this location in a planning level analysis and provide your thoughts on the design needs for the intersection. Okay, so these are the peak hour volumes which are given for each approach. They have given us how many people are going left and through. Through means straight. Through means straight. Okay, and how many people are taking the right turn. Okay, so first thing we need to do is we need to add all of them. So give me the total. You broke it. Right? Yeah, give me the total of this. No, total. Total. Okay, this is total volume of the intersection in the peak hour. Okay, I need to convert it to AADT. What is AADT? Yes. Okay, average annual daily traffic. So we have an approximate. It's an approximate. Okay, because no other data is given, so I will use approximate. That is, the peak hour volume is around 9 to 12% of the daily. Okay, so we can use 10%. Okay, so if this is 10% of the daily, then how much is the daily? Not multiplying it, dividing. What did you do? You divide by 90. So what? Okay, this is 10% of total. To get the total, I have divide by 10%, right? This is a total, right? I multiply by 10%, I will get this. Right or wrong? Okay? Clear? But this is an approximate. You can find out the actual factor. In the traffic engineering course, if you go to the slides, you will see a table for this factor. Okay? okay, right, for one example, obviously, why would I show you the table? Okay, but the point is 10% is an approximate value. Okay, it can range between 9 to 12%. It can be little bit higher, little bit lower. To get that, you have tables given in other books, and you have the data as well. You can get the data, take the data of the whole day, and you can see how much traffic is actually there in the peak hour. Okay, so this can be done, but anyways, I need the ADT, which I have got. Other thing which I need is percentage of left turning. From this total, how many people or what percentage of people are left turning? So I already, they have given me the volume of left turning from every direction, right? Okay, the percentage is not for every direction. I need the total percentage. So I will take the total of this, okay, and percentage out of the total peak hour. Okay, so what is the left turning volume?
27%.
What was the volume? 582. Okay, and the percentage is 27%. Okay, out of this one, right? Okay. Now I can use this graph to know that the roundabout should be 1 lane or 2 lane. Okay. So 27% will be somewhere here, close to 30. Okay. And my volume is 21,500 something, right? ADT. Okay. So I'm here, close to 20. Okay. My point is somewhere here. And you can see what they are saying. Double. Clear? Okay. So in this graph, you need ADT on the y-axis and percentage left turning on the x-axis. Okay. The ADT is for the total, for the whole day, and the percentage is again out of the total. Clear? Okay. And these lines are telling you whether it should be 1 lane or 2 lanes. Okay. Anything above this is 2 lane. Anything above this is 2 lane. Anything below this and on the right hand side is 2 lane. Anything below this on the left hand side is 1. Clear? Clear? Okay. Whenever we are dealing with intersections, we have a problem of safety. There can be crashes and conflicts between the vehicles. To ensure that they don't happen, we need to check for the side distance. Okay, now side distance on the intersection is different than the normal one. Okay, why? Because normal one is for which direction? The normal side distance is forward, right? How much you can see on the road in front of you. But side distance for the intersection is not forward, it's for what? How much you can see on the other side, right? No? From how far you will be able to see the vehicle which is coming from the other side. This is how you will decide whether I should stop or slow down or go fast or so on. Clear? So this is why it is different. So let us consider this case. We have this obstruction here. Since you are looking at the side, so your view is not blocked by the road itself or anything on the road. Your view can be blocked by the obstruction on the side of the road. Okay? So you must know the distance between the road and the obstruction from your side as well as from the other side. Okay? Let us call this road or this vehicle as vehicle A. Okay? So the distance between vehicle A in its lane to the obstruction is called small a. Okay? And the vehicle which is on the other road, we call it vehicle C. Okay? And this is road B, whatever. And the distance between the other vehicle and the obstruction, or the lane of the other vehicle and the obstruction, is noted by small B. So A and B is the distance from the road to the obstruction. Okay, A from one road, B from the other road. Okay, then the point at which you start to see the other vehicle. So when I am here, I can see the other vehicle now. If I am behind, if I try to see, I will not be able to see because of the obstruction. Got it? So this is the first point at which you will see the other vehicle. Okay. So distance between this vehicle and the stop line, this point and the stop line is called DA. Okay. Distance between this vehicle to the stop line is called DA. And the same distance from the other side is called DB. Clear? So A and B, distance from the lane to the obstruction, one road and the other.
And this distance must be enough to decrease.
Yes. And DA and DB are the distances from the vehicle to the stop line. Which position of the vehicle? The position from which they are looking at the other direction. Clear? Okay. So, since you already mentioned it, so if let's say DA is 300 feet. So when I look at this vehicle, I am 300 feet behind the stop line. Okay, I feel this vehicle is too fast, okay, or too big. Okay, I should stop. Okay, to stop I need 400 feet. Then this distance is not enough. Okay, so either I should reduce the speed or move the obstruction. Okay, clear? Clear or not? If I need 200 feet to stop, my distance is already 300 feet, no problem. Clear? Okay, this is how we use it. Okay, so what is the relationship between A, B, D and DB? How do I put them together in one equation? I will use similar triangles. Okay, so you see one triangle from A to the stop line to the other vehicle. This is one triangle, right? The big one. Okay, and then you see another triangle which is from the obstruction to the lane and the vehicle A. Okay, so I have this triangle, the small one, and I have this big triangle. Okay, in this triangle, this distance is what? DA. And this distance is what? Yeah, DB. Okay, so DA upon DB or DB upon DA. Okay, and for this small triangle, this distance is what? A. Now A is what? From the obstruction to the lane. Okay, and this distance is how much? Okay, the total was DA. From this total, I am subtracting B. Clear? Okay, so this is A, this is DA minus B. Okay, similar triangle means what? The ratio should be equal, right? Okay, so the ratio of DA upon DB should be equal to DA minus B upon B, right? The ratio of this upon this should be equal to this upon this. Clear? Okay, so this is what we are seeing. Okay, so now we have all 4 parameters in one equation. Okay, if you put 3 values, you can get the 4th one, right? Okay, if you put the 3 values, you can get 4th one. Okay, clear or not? Okay, any questions? Okay, so now A and B are the distance to obstructions, right? Distance to obstruction. This has to come from the site. My road is this much and the building or the obstruction is this much away from the road. So I have to measure it, I will design it, I will assume that I put the building 40 feet from the road, okay, something like this. So A and B are the site conditions, okay. D and DB depends upon but what it should be.
Must be enough to decrease the speed.
To decrease the speed or slow down, or the worst case is you stop. Okay, so must be enough to stop. Okay, so you can calculate the minimum value of DA and DB using this equation. This equation is for what? Equation for?
Back distance.
What is it?
Distance.
Side distance. What do you say?
Braking distance.
Braking distance. Braking distance only this part. Side distance. Okay, this equation is for the side distance. So you can calculate the side distances for both these drivers according to their speed and the road, the road speed and the gradient, and you can put them in this equation and you can see how much should be A and B. Okay, or you can fix A and B and see how much should be the side distance and the speed. This can be done. Clear? Clear? Okay. Sure. Okay. This is one way of doing it. Okay. There is a traditional method of doing it as well, which is empirical. Empirical meaning it works on fixed values. Okay. They did some experiments, they did some research. Okay. Put it all in one jar and then they did this, shake the jar and they came up with few numbers. Okay. We don't know from where these numbers came from. Okay. But according to them, they are saying we should fulfill this ratio for safe operation of the intersection. You must satisfy this ratio. Okay, what is this ratio? dA, the distance between the vehicle and the stop line, right? When it sees the other vehicle, the distance from the vehicle to the stop line when you see the other vehicle. Okay. So this distance plus extra how much? 18 feet. Okay, so this is the distance plus extra 18 feet. Okay, this should be so distance upon speed will give you what? Distance upon speed gives you distance. Yes. Time. Okay. So this is giving you what? Time to cover how much distance? This much distance. Okay, time to cover this much distance. This should be equal to, this time should be equal to, now this is what? Distance from the other vehicle to the stop line. Other vehicle to the stop line. Okay, minus how much? 12. So it's not to the stop line now. It is how much behind the stop line? 12 feet behind the stop line. Okay, so that one was 18 feet forward. This one is 12 feet back. Clear? Okay. Divide by the speed. Okay. Now what is 1.47? Conversion. Okay. This is not empirical. Okay. So they are saying the time required by this driver to go from when he sees the other driver from that point to cross the stop line and go 18 feet forward. This time should be equal to the time when this driver is seen till he reaches 12 feet behind the stop line, or not the stop line, sorry, the conflict point, the crossing point. Okay, so the time in which, so what will happen? This driver will see this guy, and he is deciding what? I will go. Okay, so he will go from here to here, and how much far? 18 feet more. Okay.
From B.
Yeah, from B. 18 feet more from B. Okay. No, it's not a stop line. It's crossing point. Sorry. Okay. So, when he will go from here to here, when he will reach here, this driver will be where? 12 feet back. Okay. Why 18 feet? Why 12 feet? Allah knows. Yeah, the jar. Okay, clear? This is why we call it empirical. Okay, so here we are trying to satisfy the geometry. Okay, and here we are trying to satisfy the safety requirements according to their empirical values. Okay, but in both cases we know that. So you can have this equation for dB. So dB on one side, everything else on the other side. So the equation becomes this. Okay, and then you can calculate the dA from the side distance. Okay, dA can come from the side distance, and then you can find out the minimum dB from this equation. Okay, so what if you are applying this rule, the empirical rule, then they are saying that the actual dB should be more than the minimum required. This is minimum, right? For safety, this is minimum. More is bad. More is good. More is good, right?
Sometimes.
Huh? More is better, right? Clear? Sure. Need coffee, right?
عليه وشرب ده.
Huh?
عليه وشرب.
Yeah. Okay. He's the second guy who's asking me. I look confused, right?
Yeah. Ask a lot.
Hmm?
Ask a lot.
Yeah.
We short from him.
Okay. So we have this condition here. We have this vehicle coming from this road. The speed of the vehicle is 30 miles per hour. We have 20 feet from this side, 60 feet from this side, 12 feet from this side, and 42 feet from this side. Okay. So and this is one way, so there is nobody coming from the other side. Okay. So we need to check the side distance conditions. Okay, for this guy from both directions. Okay, from this direction as well as the other direction. Okay. So first of all, using the speeds, we will calculate the side distances required by them. Okay. So side distance equation is this one. Or we just calculate for A. Give me the side distance for A. T is how much? T is 2.5 seconds. Okay, there is no gradient given, so we will assume it to be 0. Okay, the speed on this side was, yeah, no, they have written it's level ground, so gradient is 0. Speed is 30 miles per hour. 89. Okay. So this is for this guy. Okay. The one who is coming from road A. Okay. Now we'll calculate the minimum dB according to both cases. Okay. According to the case of the first case, similar triangle, and the second one in which they are using the empirical approach. Okay. So in the first case, dB actual equals to this. Okay. So what will be my dA? Tell me. What is my dA? dA, the side distance which is required by vehicle A. Okay. So you will put this as dA. Okay, A and B are the distances to the obstructions which are given here. Okay, distance to obstructions. So 20 this one, this is A, and this one B, this one will be B. So how much is dB actual? What? Okay, any question, any problem?
A Victor 60.
Which A? Small a? Small a is the distance 20. It's to this car, right? When we take it for this car, it will be 60. You're going for this direction, right?
Okay.
It depends upon direction.
37.
37. 37? No, I'm asking others. 37? Okay. Now dB minimum. We should check it with dB minimum. Okay? This value should be more than the minimum or equal to minimum. Okay? Okay? So one way of doing it, the first way is using the side distance. What is the side distance for this car? What is the side distance required for this car? The car B. What happened? DS is wrong. How much is it?
196.
196. Hmm.
Yeah, 196.5.
Okay, then this will also change. Okay, how much is this? This will become your DA. This will be a DA. Huh?
38.
Still? It was 890 something, now it is 196. All the, okay. Okay, same value?
B is 40.
Huh?
B, how much?
B is this one. 40. Huh?
25.
25.4.
It's I Oh,
Okay. Okay, this is the actual distance available to this guy to stop. Okay. How much is the minimum required to stop? Calculate the side distance for the B vehicle now. This vehicle. So the speed will change. Hmm?
300.
Okay. Okay, any questions? Is it clear? Everybody? Yes? Clear? Huh? Okay, so on the, what do we find out from here? Tell me. What do I know now? What do I say about this intersection?
Required side distance. B
Huh?
and required side distance for B and
Not safe.
Not same. Okay, because your actual dB is only this much. When this guy sees the vehicle here, he has only 25 feet behind the crossing point. Okay?
And minimum required.
And minimum he requires is this much. Okay?
Crash.
Hmm?
Crash.
Yeah, they will come.
What about Eric? We can go stop line for A. to all
Yeah,
of-
this is how you decide
Okay.
what to do. Okay? This is how you decide. We have the second approach as well, which is the empirical approach. This one. We put dB minimum as a side distance, right? But they are saying it's something else. So let us take their approach and see how much dB minimum according to their approach. Okay, so what will be my dB minimum according to this one? SA and SB are the speeds. We already had the conversion factors in the actual equation. No need to convert it again. 298. Okay. Even according to them, the minimum is minimum required is more. The actual is less. Okay, so in both cases we won't have enough. Okay, what about the other direction now? If I'm doing it, yes.
What's the difference between BSP and PB?
Sorry.
What's the difference?
This is actually what he has, and this is what he needs. This is according to the side distance standard, and this is according to the empirical rule. Okay. The other side. For the other side, this will not change. This will remain dA. Okay. So when we are calculating dB actual, dA will remain the same. Okay. A will be on this side now. So A is 60 now. Small a is 60. And small b will be for this vehicle, which is 12. Okay. So for the other side, what is my dB actual? dA is the same. dA is the same. Okay. A and B will change. Sorry?
DC actual.
DC actual, no problem. We are putting it as dB in the equation. How much is that? 63? Okay, so this is actual, then minimum. This one has 40 miles per hour speed, same speed. Okay, so the minimum according to side distance standard will be the same. Okay, and your actual is less than the minimum. Clear? Okay. What about this approach? If you take dB minimum using this one, then your dA is the same. Yeah, everything is the same. It will not change. The speeds do not change, right? The speeds are same, and dA is still the side distance of the first vehicle, which will not change. Okay. So even to the other side, we don't have enough side distance available. Okay. Now what are the things we can do? He already mentioned one thing, which is what? Put a stop sign for this guy. Okay, we can reduce the speed. Okay, and then you can redo the calculation and see what happens. Okay, or third thing is what? Signal. Okay, anything else? Anything to do with the design? Very good. Then you will say nothing.
Will it use the obstruction?
Yeah. If there is any opportunity to move it back, okay, this will also increase the side distance. Okay, this will also increase the actual distance.
المعقول ما تكسب الزيوت.
Okay,
In test, how question will come?
Huh?
For A or Q?
this is how it will come.
Because not written plus C.
Hmm?
There is no.
Yes, I will not write question. I will not write question.
You see actual is
Feet.
Sorry? Yeah, feet. Okay, any question? Okay. Now this example gives you an idea about warrants. Okay. What is a warrant? Warrant is a condition in which a specific control device is required on the intersection. Okay. Warrant is a condition in which a specific control device is required or becomes required for the intersection. Okay, like we saw in the previous case. Okay. Now you cannot leave it without the a control device, right? That intersection cannot be left without a control device. Okay, because drivers do not have enough sight distance. Okay, but like he mentioned three things: put a stop sign, put a signal, put a kubri, and so on and so forth. Okay. So which control device we should use? Okay. So then we have to look at other things as well. Okay. So in the manual of uniform traffic control devices, there is a manual. It's called Manual of Uniform Traffic Control Devices. This manual lists down these conditions for each type of control device. For example, these are the warrants for putting a stop or yield sign. Yield meaning give way. Yield means give way. Okay. So according to them, you can put a stop or yield sign if one or more of these things happen. So if you satisfy any one of them, it's enough. You can put a stop or a yield sign. Okay, what are these conditions? Intersection with a less important road, so main road and a secondary road, a small road. Okay, where application of normal right of way would not be expected to provide reasonable compliance to the law. Okay, so it's a small road which is intersecting with the main road, and because of the high speed of the road, you feel that if you just leave it to the drivers, there will be too many violations. Okay, there may be too many violations because of their speed or because of the drivers who are not waiting on the other side. Okay, a street entering a designated through highway. Okay, so we have a street entering. Okay, entering is different than intersection. Entry point is different than intersection. Okay, intersection, then the highways are crossing each other, so there's a left turning as well. Entry means there's only right. Okay, so you can use a stop or a yield sign when you have a street which is entering a through highway, straight highway. Okay, and you can use so the area is unsignalized. The area is signalized. In that area you have signals. So before this highway you have a signal, or before this intersection you have a signal. You have signals on other sides as well. Okay, between them there is a small intersection where you don't think that putting a signal will be feasible. Okay, so on the intersection you may use a stop or a yield sign. Okay, so if any one of these conditions meet, then you can put a stop or a yield sign. In addition to these three, a stop or yield sign can be used intersection of two minor streets as well. Okay, or local roads having three or obviously where one of these conditions meet. Okay, so these three are applicable where there is a major road. So at least one of the road is a major road. Okay, if both of them are minor roads, then check if one of these three conditions is met. Okay, so these three belong when there is at least one major road crossing, and these three are when both of them are minor roads. Okay, So the total volume of all road users, total meaning all road users meaning vehicles, bicycles, pedestrians, total of all of them from all directions is more than 2000. Okay, so all road users, all directions, okay, it's more than 2000 units per day, then you should think about putting a stop sign or a give way sign. The ability to see, the one which we just saw in the previous example. In the previous example we didn't know, right? Major road, minor road, we didn't know. Okay, volume, we didn't know. But just by looking at the distances, we know that we need something. Okay, so this was this condition. Okay, so the side distance not enough, or none of these conditions exist, but the experience says that we need a stop sign. Why? Because there are crashes, there are accidents which are happening. Okay, because of any reason. We check the conditions did not satisfy. But we still have 2-3 crashes. Okay, there is a limit given here. How many? Where is it? 5 or more. Okay, 5 or more. Okay, so if these many accidents are happening, okay, then we consider putting a stop or a yield sign, even if none of these things exist. Okay, this is expert experience. Okay. And 5 or more for 3-year period, and there's another one, 2 or more for 2-year period. Okay, but there is one thing which you have to see when you have the accidents. You have to see which type of accidents you are having. Okay, is it because of the drivers entering the intersection when they should not be entering? Is it because of that, or is it because of some other reason? Okay. So, for example, you are having accidents because the pavement is slippery, so vehicles are getting out of control. They are, So this has nothing to do with stop sign. Even if you put the stop sign, what? Drifting. Yes, listen. Okay, so you have to see what type of accidents you are having. Okay, if the accidents are between 2 vehicles, okay, which are entering the intersection together, you can think about putting a stop sign. If it is because of a pedestrian crossing, again, a stop sign can be thought about, but otherwise, you have to look for other things. Okay, so this thing is very common. This warrant is common in other for other things as well. So this is for stop and yield, right? Okay, there's a limit of crashes for signals as well. There's a limit of crashes for 2-way stop sign as well. Okay, so you will see this condition very often, and this one as well. This one is about what? The side distance, and this one is about the crashes. Okay, so you will see it happening or coming up again and again. This is for 2-way stop sign. Okay, so 2-way means stop sign here and the other side. Both directions will have stop sign. Okay, for the same road, both directions the same road. Okay, having the stop sign. Okay, yeah, a stop sign should not be used at any intersections which already have a traffic signal, because it will conflict. Signal is green and there's a stop sign, it will conflict. So at no approach of the intersection which has a signal, the stop sign should be used. Secondly, a stop sign should not be used for speed control. Okay, the drivers are coming too fast, and because of the speed the accidents are happening. Like I mentioned, vehicles going out of control. So let us put a stop sign, because then the drivers will slow down. No, stop sign is only when the crashes are happening. Okay, when you need it for the intersection, not because to control the speed. So in these cases, you don't use a stop sign, signal and for speed control. Okay, where can we use a 2-way stop sign? Yeah. So first condition is that you have already used a give way sign. Okay, you already tried using a give way sign or a stop sign on one side. Okay, and you think that it's not working. Okay. So if you have a major road and a minor road, a major road crossing a minor road, where will you use the stop sign? On the minor road. Okay, so these conditions are for them. So again they are saying one or more of the following conditions. The first condition is related to the volume. The volume on the through street, meaning the major road. The volume on the major road is this or more. Okay, both directions. Okay, volume on the major road is more for both directions, for the major road only. Okay, in the last case for total. Here only major road. Side distance. Side distance is a problem. Okay, so and it's a problem for both directions. Last one, crash experience. Okay, and again the numbers are given. It should be this much in this time and so on and so forth. And as I told you, you have to look for what in crashes? Reason. Okay. Okay. If you decide I have to put a stop sign there, then you have to go. Who is this?
My friend.
Who is your friend?
We can go and
Tell me his name.
we can go together.
Huh?
Brother Hamza.
Is your brother?
No.
Like they have two of you in the world?
Imagine you have two of you.
Yes. Okay. We will not be able to complete it. Okay, we will do it next time.